Welcome to implementing pull to refresh and infinite scrolling. After watching this video, you will be able to define pull to refresh with a breakdown of the process, describe infinite scrolling with a breakdown of the process, describe use cases of pull to refresh and infinite scrolling, describe how flat list and section list implement these features. Pull to refresh is a common feature of mobile apps on all platforms, irrespective of the language they are written in. This feature allows users to manually refresh the content on the screen by pulling or dragging the screen down with their fingers. Once you pull down, an indicator usually appears on the screen, which shows that new data is being fetched, and the app updates the content displayed with the new data. Let's look at a breakdown of the pull to refresh process. Pulling, the user pulls down on the list, triggering the pull to refresh gesture. This typically updates the UI to indicate that a refresh is possible, and in most cases, a loading indicator appears until the data is fetched completely. Threshold reached, the user continues to pull down until a certain distance on the screen to ensure that the refresh is not triggered accidentally. Released, the refresh is triggered when the user releases the pull gesture. This is when the actual data fetching happens. Data fetching, the app fetches new data from the server or updates the existing data asynchronously, meaning that the data fetching happens in the background. The app does not freeze or stop responding while it waits for the server to send the requested data. Updated data, the app updates the list with the new data, and the loading indicator is hidden. Infinite scrolling is a technique used to dynamically load more content as the user scrolls down a list or view. This is especially useful for applications with large datasets or content that needs to be displayed progressively without requiring manual pagination. The infinite scrolling process includes the following steps. Initial data load. When the component renders, the initial set of data is displayed. This is typically a limited number of items, such as 10 or 20 list entries. Scroll event detection. Both flatlist and sectionlist components provide on-and-reached and on-and-reached threshold props to manage infinite scrolling. The on-and-reached event is triggered when the user scrolls almost to the end of the list visible on the screen. The on-and-reached threshold prop determines how close to the bottom the user needs to be before new data is fetched, the default being 0.5 or 50% of the list size. Data fetching. The app fetches the next batch of data from the server or local storage asynchronously, similar to how it happens in pull to refresh. The app does not freeze or stop responding while it waits for the server to send the requested data. Appending new data. The fetched data is appended to the existing data in the component state. The state management ensures that the list automatically re-renders with the new items, creating a continuous scroll experience for the user. Handling user interaction to prevent multiple requests from being sent if the user scrolls through quickly. This can be achieved using debounce, where the fetch happens only after the user has stopped scrolling for a certain period, or using on-momentum scrollend instead of on-and-reached. Think about the amount of data that is generated on social media daily. When you have such a large set of data or content, pagination helps you break it into smaller, more manageable pages. But it is not feasible to have pagination on mobile apps. Pull to refresh and infinite scrolling come to the rescue. These features help users navigate through the information more easily rather than loading everything at once. In most social media apps or mailboxes, you will find the pull to refresh and infinite scrolling. For example, on Facebook, when you swipe from top to by an inch, the loading indicator appears and the new feeds are refreshed. On Facebook or any other social media, you can keep scrolling and the next batch of data in reverse chronological order are retrieved. Let's see a code example of pull to refresh. This code simulates a pull to refresh by retrieving data locally instead of sending a request to the server. As you can see, there is an initial list. When the pull and release happen, the loading indicator appears and the list is appended with new items. The code, when implemented, shows the output as shown in the screen grabs. The example shows 5 items, and when the user pulls and releases, the loading indicator appears as shown. In this example, you see there are 10 items. But as the user scrolls down, the loading indicator appears and more items are loaded. Let's look at the code behind the scrolling. In the code, First, the initial data is set to 10 items. Stop fetching if already loading. Then you add an asynchronous call to request data. When response received, refresh data using state and set loading, false. Use the handler handle load more only if it is not already loading. The following props are used with the flat list to achieve the scrolling, unenraged, and unenraged threshold. In this video, you learned that pull to refresh allows users to manually refresh the content on the screen by pulling or dragging the screen down with their fingers. An indicator usually appears on the screen, which shows that new data is being fetched, and the app updates the content displayed with the new data. Infinite scrolling is a technique used to dynamically load more content as the user scrolls down a list or view.